All right, so this is the last section for chapter P. So it's P-7. I'm going to make it easy on you if you pay attention and ask questions as I go along, because inequalities can be difficult depending upon how you look at it. So P-7, solving inequalities. Algebraically and graphically. I will always graph it no matter what, just because it helps you with the solution, especially with inequalities. So example 1. We are going to solve absolute value x minus 4 and absolute value and less than 8. So it's important to note this is actually on a number line because x is not squared. So I know it's in the one-dimensional number line. And pay attention to your inequality sign. Make sure that your absolute value sign is on the left side. You don't want it on the right side. If it's on the right side, then flip your inequality, which implies you have to flip the sign. So that inequality being less than means I want my absolute value to be less than 8. Isn't less than 8 to the left? Okay. This is going to end up being a sandwich statement. It's an and statement. Now with inequalities, we generally write two different inequalities. So if there's an equal sign here, if you recall, you would have written x minus 4 equals 8, just like it is without the absolute value sign. And then you would have written x minus 4 equals negative 8. With inequalities, we have to flip the inequality sign. But when it's less than, I already know it's going to be a sandwich statement. So instead of writing two different statements, we're in pre-calc, we can write the first statement is exactly as it looks. And then for our second statement, we actually do flip the sign. It doesn't look like it. You keep the same less than sign, but if I read it backwards, isn't it saying x minus 4 is greater than? Right? So I really have flipped the sign. It just doesn't look like it. We'll read it backwards. And then the negative 8. So the part that you have to add on when you take off the absolute value sign is this part for your sandwich statement. So you keep the same sign, which really means we flipped it, and change the sign of that number. In this case, positive 8 to negative 8. If it were a negative 8, we'd make it a positive 8. Technically, the absolute value of something cannot be less than a negative number, can it? Because it's going to come out positive. All right, so let's go ahead and solve this. There are actually 3 parts to this inequality. There's a middle, a left, and a right. My goal is to solve for x. So what do we do to all 3 parts? So add 4, add 4, add 4. So I end up with an x in the middle. My less than signs did not change because I did not multiply or divide by a negative. I've got a 12 on the right and a negative 4 on the left. So algebraically, this is my solution. X is less than 12 and x is greater than negative 4 is how that's read. Now they may ask you for interval notation. And with the sandwich statements, well, let's just go ahead and graph this so that we can see why the interval notation is as it is. And we're just going to sketch the graph, so I'm not going to try to make my hash marks exactly equal for today. I have little time and too much to do. So like 12 would be out over here somewhere. So am I including negative 4 or 12 with a less than? Yes or no? Nope. So I'm going to have parentheses, and I'm just going to look at the left side first. If x is less than 12, that means my parentheses opens in the direction that my arrow goes, which would be to the left. And if x is greater than negative 4, it's going to open in the direction of greater than, which is this way. And wouldn't there be a line in between? So that implies that my interval notation would look like negative 4 and 12, with parentheses. So they could ask you for the interval notation. It's not an ordered pair, it's interval notation. So that's a review totally. True? Okay. Let's look at an or statement. So example 2. You are to solve the absolute value of 3x minus 2 and absolute value greater than or equal to 5. Because of the greater than, not just the equal, so it's just the greater than part. That's the part I'm really concerned about. That part tells me that I have an or statement. And if you have trouble remembering, well, which is the sandwich and which is the or statement, don't or statements tend to go like this in opposite directions? Right? So if I'm looking at that statement, this has to be greater than 5. Greater than is going in that direction. That looks like my arrow is going like that, whereas and statements tend to look like this. You have endpoints and then the arrow intersects in between. That's a less than here. This is a greater than here. So that kind of helps you remember which is going to be your or and which is going to be your and, because they look different when you set them up. So for the or statement, we're going to write 2 separate statements. You cannot sandwich an or statement. So you must write 2 separate statements. So the first statement, and your book will do this backwards for a good reason, but I choose not to. Drop the absolute value sign and write it just exactly as you see it. 3x minus 2 greater than or equal to 5. And then you must have the word or. If you miss it, you lose points in your solution. Then for the second statement, you're going to write the 3x minus 2 without the absolute value signs, but you're going to flip the inequality, in this case to a less than or equal to, and change this to its opposite sign, negative 5. Solve those separately. So we would add 2. So we have 3x greater than or equal to 7, divide by 3. X is greater than or equal to 7/3. Or, don't forget that, on the right side when you add 2 and a negative 5 gives you a negative 3. When you divide by 3, you get a negative 1. I did not divide by a negative, so I don't flip that inequality. It's an or statement if it's greater than or greater than or equal to. So the minute this is a greater than, it's or. If it's a less than, it's an and. So this would be my algebraic solution. And you can write it that way. You can also flip these around where you have the x is less than or equal to negative 1 first, or x is greater than or equal to 7/3. Don't write that as a decimal. Negative fraction. What? Okay, so with Math Excel, they might accept this. It depends on what they're asking for. If they ask for interval notation, now we're going to graph it to see what the interval notation would look like. So I'm going to graph this to help with that. So my 2 boundary points, this is negative 1. Put 0 here. 7/3 is what mixed number? 2 and 1/3. So 2 and 1/3 would be, oh, I don't know, right about here. So this is 7/3. So you got to label it. So for this one, it says x is greater than or equal to 7/3. Are we including 7/3? Yes, and we're going greater than, so I want a bracket opening the direction my greater than arrow is going to go. So it opens to the right, and it goes infinitely to the right. X is less than or equal to negative 1. Does it include it? Yes. And it's going to the left, so I want my bracket opening to the left, and an arrow infinitely to the left. So now looking at that, I can actually write my interval notation. So for the interval notation, look at this part of the graph here. What's the leftmost boundary point here? Negative infinity. What's the rightmost boundary point? Negative 1. We are including negative 1, so there's a bracket. There's always a parentheses on infinities. Then look at this part of the graph. What's your left bound number? 7/3. And we are including it, so it's got brackets. What's the right bound number? Positive infinity. And we always have parentheses. So to finish this off, we have to show that we want to combine those two together. So we use a union statement. And it looks like a U. But you must use the sidebar tools in Math Excel and choose their U. It could be under the More button. But if you try to use the U on the keyboard, I doubt they'll accept it. You can try it, but I doubt they'll accept it. And so this would be the interval notation. So pay attention to how they want the answer done. And then they might ask you to graph it. So that's everything that they could possibly ask you on that type of question.
Ms. Mary,
yes.
Use the U only in the OR statement?
Correct.
Okay.
If you've got two different intervals, in other words, I can't be here and here at the same time, then you're going to have a U. But if I've got just one interval, I can be here in between those at the same time, there's no U.
Okay.
And we're going to talk more about intervals as we go along. Yes?
So, if the interval is less than, it's an and statement, and if it's greater than, it's an or?
Correct. And if it's greater than, then that means you're going to have a union, like this. If it's and statement, you shouldn't have a union. Most likely you won't. I'm trying to think of a situation where you would. I can't. Off the top of my head. Okay, so let's flip that. Let's now look at what happens when we go into the coordinate graphing system. So example 3. You are to solve x squared minus x minus 12 is greater than 0. Once we hit x squared, it's no longer on the number line. And you can't say you have an and statement and an or statement. Okay? You need to graph these to see what the solution is. Whether they tell you to graph it or not, you need to graph it. The first thing I'm going to do is try to solve algebraically if I can. So if I multiply these together, my bookends, 1 times negative 12, I get a negative product of 12. What does that mean I'm doing with the factors of 12? Am I adding them or subtracting them? Subtracting. So I'm subtracting the factors of 12. I'm looking for my middle term of negative 1. What factors of 12 subtract to give you 1? 3 and 4. And so my 1 is negative. The bigger of the two always carries that sign. What does the sign of the 3 have to be? Positive. I do not have to do what we term here at Horizon as group and garbage because I have a coefficient here of 1. So I can just throw those neatly into my parentheses. I'm going to revert now to an equals to 0 because I don't need the inequality yet. And so my x squared becomes x and x. And then my plus 3 and my minus 4 are put in my parentheses. I'm ignoring that right now. We'll come back to the greater than 0 when we're ready to graph it. So then if I have a product that is equal to 0, one of the two factors must be equal to 0 as well. So we're going to set the x plus 3 equal to 0 and the x minus 4 equal to 0. And the reason why I dropped the inequality is because it doesn't have any effect on the solution. And in fact, the inequality could be wrong. So we'll look at the final graph when we're done. So here my boundary points are x equals negative 3 and x equals 4, right? This parabola is going to cross the x-axis at negative 3 and 4. So we're going to sketch this graph because I need that sketch in order to continue. And you have a problem exactly like this on your test on Friday. The minute I ever heard a professor say, you have a problem exactly like this on the test, what do you think I did? No, I put on there test question, or I highlighted it. You know, I don't know how many times. Well, some of you have had me before. Some of you have had me twice before this year. And I've said this often. And I always mean it. And they always appear on the test, and you seem surprised. I'm like, I told you that was going to be on the test. Sometimes it's a word-for-word problem. There should be no excuses for missing it. All right, so put in your boundary points of negative 3, 1, 2, 3, bless you again, and positive 4. Now I know that this graph crosses the y-axis at negative 12 because that's my y-intercept. kind of a pain. I'll try to make it not that big. So I'm going to go by 2s. 1, 2, 3, 4, 5, 6. So this is negative 12. So I'm going to go by 2s. So I know it crosses here. So then I'm going to put this in my graphing calculator. So go into y equals and type in x squared minus x minus 12. And we get the following graph. I expected it to open up because the x squared is positive. And then I'd like you to find the vertex. How do you find the vertex? Second calc. What am I looking for? Yeah, I want a minimum. Isn't that vertex a minimum because it's at the bottom? So I want to choose minimum. It's looking for left bound. Well, I can't see my cursor, but I know it's on 0. That means it's all the way at negative 12. So just move your cursor so you can see it flashing, and there it goes. But now it's flashing. Hit enter. And move your cursor for right bound until you can see it flashing again. There it is. Hit enter and enter again. So even though I can't see my vertex, I know it's at about 0.5 is about a half, right? And then negative 12 and a quarter. So I'm at a half and negative 12 and just a smidge, right? So here's our sketch. Bearing in mind that oops, wow, that was really off. Bearing in mind that my scales are different on the x and y axis. So this is a negative 3 and this is a positive 4. That's a sad parabola, so I'll apologize, but there it is. Now, here's how we get the solution. We are going to look at our intervals. What this does is it cuts the x-axis into 3 pieces. If I cut something twice, I cut it into 3 pieces. Here's one piece over here, one piece in between, and one piece to the right. Agreed? That means I have 3 intervals. If I have 3 places where it crosses, I'm going to have 4 intervals. If I have 4 places where it crosses, I'll have 5 intervals. I always have one more interval than the number of boundary points. So here, I'm going to ask you the following question. Name all the intervals. When you name the intervals, you just name them with parentheses. Don't worry about whether it's included or not. Just name it with parentheses. For the final solution, you'll do brackets and unions and that kind of thing if necessary. So the intervals, this is the first interval. What's the leftmost boundary point on this interval? Negative infinity. So I have negative infinity. What's the right bound? Negative 3. Next interval are between these 2 boundary points. So what's your left? Negative 3. And your right? Positive 4. Last interval, what's your left? 4. And what's your right? Positive infinity. So one or more of these intervals are the solution. Here's how we find the solution. Now we go back and focus on the fact that it's a greater than sign. And in this case, when it's a greater than sign, we are looking for the part of the graph that is above the x-axis. That's the part that we're looking for. The x-axis is your cutoff point, and this is saying greater than 0, because remember this is y. Where is y greater than 0? Isn't this the part of the graph that's above the x-axis only? All of this is below the x-axis, agreed? So look at your intervals. Does this interval from here to here contain the part of the graph that's above the x-axis? As x gets more and more negative, won't y get more and more positive? So this is one of our solutions. So this interval here is one of our solutions. What about the solution between here and here? It includes this part of the graph. Isn't that under the x-axis? We would only choose that if that were a less than sign, and it's not. So this is the other part that's greater than, and this is the part of the graph that includes that. Isn't that this interval over here? Because I have 2 intervals, I know I'm going to have union notation. So then my solution, or solutions, I guess it's really my solution. I don't know. It doesn't matter. Would be this interval here. We always have a parentheses at negative infinity. Because of the greater than, am I going to have any brackets here? No. So I know I have parentheses. And then I'm going to include this interval. And because there's two of them, I have a union between them. So this whole thing is the solution. Does that seem reasonable and understandable? If I had changed this inequality sign to less than, all the work would be exactly the same. But now this is the part that's under the x-axis, so this would have been the only solution. No need for union notation. Okay? Yes. Say that again. Yes, and remember your U is found in Math Excel on the tool, the little toolbar that's in the left side, and it might be under the More button. Okay? But I would not be using the U on your keyboard. I don't think they'll accept that. Try it, they might, but I haven't put that in yet. All right, so then let's look at example 4. This one actually had a solution. It is possible to have a no solution or an infinitely many solution with graphs in the coordinate grid system. So let's view when that happens. So example 4, we are going to solve. We're actually going to put 4 and 5 in the same spot, but 5 requires the same work as 4, because I'm just going to flip the sign. So we've got x squared plus 2x plus 2 is less than 0. So because it's less than 0, what does that imply? That would be below the x-axis, right? But we'll do that in a minute. Now, let's first try to solve it algebraically. If I multiply my bookends, 1 times 2 is 2. It's a positive product. What does that mean I'm doing with the factors of 2? Adding or subtracting? I'm adding. The only factors of 2 are 1 and 2. If you add them together, do you get 2? No. So this is not factorable. So then before I go to the quadratic formula or completing the square, which either one would work here, I'm going to go directly to here, and I'm going to graph it first, because I'd like to see what it looks like. It'll give me an idea. So I'm going to throw into my graph this x squared. So x squared plus 2x plus 2. Hit graph. What happens? It's not intersecting the x-axis at all. So it doesn't cut our x-axis. So what this means is your solution is either all real numbers, the entire x-axis, or none of it. One or the other. It depends on your inequality sign. So let's go ahead and sketch this best we can. I can tell you now where it crosses the y-axis. Where does it cross the y-axis without even looking at the graph? At positive 2. So the only thing I would expect you to graph on here would be the fact that this is positive 2. Find your vertex by using, is this a min or a max? The minimum. So the second calc, minimum. So go to the left, enter. Go to the right, enter. Hit enter again. That's about what? Close enough to negative 1, 1, isn't it? So that's all I care about. Those are your critical values. I'm going to label this as 0, 2, and this as negative 1, 1. Now, what is the solution? How much of the graph is below the x-axis? Because this is less than. None of it. So what's the solution? No solution. So you're going to write yourself the following note. Since none, but you're going to forget why, of the graph is below the x-axis, there is no solution. You just have to write no solution, but these are your notes. You're explaining yourself. Then example 5 you can squeeze in right here in the same place. Because example 5 you are to solve x squared plus 2x plus 2, but this time greater than 0. So it's the same graph. This time we want to know, this is implying what? Greater than means what? Above the x-axis. How much of the graph is above the x-axis? All of it. So how do you term all of it? In interval notation, how do you do that? What's the leftmost boundary of the entire number line? Not negative. Negative infinity to positive infinity. That shows all real numbers. So since the entire graph is above the x-axis, the solution is all numbers. But in interval notation, that would be written as negative infinity to positive infinity. And that's how MathXL is going to want it written. So does that make sense to you? When you don't have an intersection on the x-axis, you're just looking, is it above or below? Yes or no? All real numbers or no solution. All right, so last question is a word problem. Are we good? No complaints? All right. So there's two parts to this word problem. Oh wait, I don't want to do a word problem yet, I forgot. I have to do a cubic. It's hard. We're all excited it was the last one, I totally lied to you. All right, we're gonna solve x cubed, but these ones are actually quick because you can only do them graphically, plus 2x squared, well, for now, minus 1, greater than or equal to 0, graphically. Even if MathXL doesn't tell you graphically, that you don't know how to factor that yet. So that's what we're going to do. We're going to put this in our graph. And when I put this in my graph, something interesting occurs. So I'll clear out what was in there. And let's just put this in our graph. We've got x cubed, so I have to use my caret, plus 2x squared, and minus 1. Can you tell how many times it crosses the x-axis? It looks like twice, but how do you know it doesn't go up and come back down? Really tiny, isn't it? If you get a graph like this, you better zoom in on it. And so if I were you, I'd write the instructions to zoom in on your calculator. So here are the instructions. You've got to hit the trace button. Because wherever you put the trace button, that's going to tell the calculator where it's zooming in at. And so then, comma, you will move the cursor to the middle of where the graph hits the x-axis. In other words, in the middle between the leftmost 0 and the rightmost 0. So you'll just estimate that. And then comma. Then you're going to hit the zoom button. And then from there, you're going to choose zoom in. And then you have to hit enter, because it'll look like nothing happened. You must hit enter for it to actually zoom in. It'll bring you back to the original graph, but you have to hit enter. So here's what we're going to do. Let you write it down. Are you ready? All right, so here's our graph. We're going to hit trace. Let me move that up. We're going to hit trace. Right there. And then I want to move my cursor. It's kind of down here. I want to move it to the left so it's somewhat in the middle between where my left and right bound zeros are. And then you're going to go to zoom. And number 2 is zoom in. So that's what I'm choosing. And it looks like nothing happened until you hit enter. And then it's going to adjust your window for you. And now I can see that it hits how many places? 3. So then this is step 1. So step 1. Step 2, find your zeros. So I'm going to find my zeros on my calculator. I'm going to list them out because I have to find my intervals. Yes. Let me see. Bring your calculator up here. Let's do. Let's see what yours does. You didn't hit enter. Not I have the magic touch right. All right, so how do we find our zeros? Under what menu? Calc. So I'm going to find my leftmost zero, so I'm going to go below the x-axis. Hit enter. Go above the x-axis. Hit enter, and enter again. So we had an agreement on rounding rules, so we're rounding to 2 places, so it's negative 1.6, what? 2. So 1 0 is negative 1.62, comma. Now find the next zero, second calc, 0. Now I want to go above the x-axis, go closer to it, below the x-axis, hit enter, and enter again. You get a fabulous on the dot 0. Yes? You didn't go leftmost. Let me see what you're zooming in on. Because you did the second one, not the leftmost one. Let me see your calculator. So see where your cursor is? You're at the negative 1. But if I go second calc to 0, I'm going to go below the x-axis. You went above. I want to go below, all the way down here to below. Does that make sense? And then hit enter. And then I want to go above, and it's just slightly above. Hit enter again, and enter again. Now you're at that left. You just didn't go left enough. All right, so then let's find the rightmost 0. So second calc, 0. So this time I'm going to go below the x-axis, have a lot further to go. Hit enter, above the x-axis, enter, and enter again. That would be 0.6 what? 2, which is typical for cubics, 0.62 to repeat themselves. Okay, so those are my zeros. So I'm going to just sketch this graph because I want to see. So then step 3 would be to sketch graph. I want to see what the graph looks like, and I'm going to sketch it similarly to what they have here. I'm going to stretch out my scale a little bit. So this is going to be positive 1 for me. So negative 1, negative 2. And I really don't care about my dips and curves for this particular one. So I've got a point here at negative 1.62, which is a little bit over halfway. So this one is negative 1.62. Then this one is exactly at negative 1. And then this one is over here at about 0.62. So those are my breaks. I'm going to sketch in what that looks like. So I'm going down, up. I know it crosses the y-axis at negative 1, doesn't it? That's my y-intercept, and back up again. That's what my zoomed in graph looks like. So my 3 boundary points cuts this into how many intervals? All right, so number 4, your intervals. We're looking for 4 intervals because we have 3 boundary points. What is your, here's the first interval. What's your leftmost number? Negative infinity. What's your rightmost number? Negative 1.62. Even though it's an equals to and we're including it, just put parentheses on your intervals. We'll worry about the brackets when we actually do the solution. Then this is the next interval. So we've got negative 1.62 comma, negative 1 is the right bound one. Then this is the next interval, negative 1 comma 0.62. And then the final interval, your left bound is 0.62, your right bound, positive infinity. So one or more of those is our solution. So then to do the last part, which is our solution, we now look at the inequality sign. I haven't paid attention to it up until now. Look at that inequality sign. It means what? Above, because it's greater than the x-axis. The equals to just means that we're going to have brackets in it. So the only parts of the graph that are above the x-axis are from here to here and here. Agreed? Looks like the Loch Ness Monster. Just having fun with math. You could draw your line into the Loch Ness Monster if you're an artist. I'm not, so that's as good as it looks. All right, so our solution, which interval is this? It's this one here. And which interval is this? This one here. So I need to write with brackets. So this interval has brackets because they're both numbers at negative 1.62 comma negative 1, so there's brackets there. This interval has a bracket at the 0.62, and but at infinity, it has the parentheses. Now what goes in between? The union. There's your solution.
Wait, Miss Mary, how do you know they have brackets?
Because of the equals to.
Oh.
So anytime I actually have a number, when that equals to is there, I'm going to put brackets. The infinity never has brackets.
Okay.
So does that make more sense then? Doesn't matter if it's a cubic or a quadratic. Greater than is above the x-axis, less than is below the x-axis. And the equals to just tells you if you have brackets versus parentheses. Simple, right? Don't make it any harder than it is. All right, last question. Now I promise you, this is the last question. Example 7 is a word problem. A projectile. Your math textbook, for example, is launched straight up. Better get out of the way though. From the ground. That's important. We'll see why in a minute. From the ground level with an initial velocity of 288 feet per second. So that's not even the question, that's just information. So get that written down, we'll talk about the question. They may or may not give you a formula for this. If they don't, I'll give you a formula for this if I did. I won't expect you to memorize this particular one. But they may not. So here's the general form for projectiles being launched. If you think about a projectile being launched, even if it's straight up, it's still a parabolic arch because gravity is going to pull it down. So you did some of this in Algebra 1, 2, possibly 3, 4. So you've got the general formula of S, I'll tell you what all these things mean in a minute, equals negative 16t squared plus v sub 0 t, so those are being multiplied together, plus s sub 0. This is too long to write, but this plain s is just the height at any particular time t. So s is your height any time along the projectile path. The negative 16 is because we're in feet per second. If it were meters per second, this coefficient changes. It's negative because we have an upside down parabola, right? That's why it's negative. The t is for time. V sub 0, this is your initial velocity. So this is initial velocity. Didn't they give that to us here? Initial velocity of 288. So this right here is my V sub 0 equals 288. T we said was time. And then this S sub 0 is the height, is the start height. So the height at start. In other words, before it was launched, what height was it launched from? So from this one, it was launched from the ground, correct? So if it's from ground level, what height is that considered? 0. So that means that S sub 0 is equal to 0 feet. I could have said launched from 10 feet, from a 10-foot tall building, and then you would put 10 here. If we launched it from a 10-foot deep hole, you'd be launching it from negative 10. Does that make sense? So think of that, ground is 0. Below ground is negative, above ground is positive. Yes. The S sub 0? The plane S is the height at any time along the parabolic curve. Okay? All right, so we are ready to start. You're going to create your own formula. So step 1, create your own formula. I haven't even asked the question yet, but we can create our own formula. So we have S, because that's the question that they're going to ask you, is at what height? So there's S, we don't know that. Negative 16t squared. We don't know the time either. But I do know initial velocity. So initial velocity is getting replaced with a 288. And it's always positive for initial velocity, because we're not stopping, we're going. And then times t. And then I'm going to put here, just for our note purposes, this would be plus 0, because our initial height at which it was launched is 0. So that's not going to affect it. Technically, that's my equation, isn't it? Okay. So then here's the actual first question. So part A. When will the projectile be 1,152 feet? Now let me give you a little clue. I'm not going to show a straight up path, but I'm going to show, typically when something is launched, and this one's from ground level, so this is ground 0, it's going to reach this height of 1152, unless that's the maximum height, which is the vertex. This would be 1152 feet here, and this would be 1152 feet here. Won't it reach it in 2 different places? It'll reach 1152 feet on the way up, and then on the way down. The only time it won't reach that height in 2 different times is if it actually is the vertex, the highest point of that parabolic arch. Then it will only have 1 time. Ground level has 2 times, times 0 would be here, and then the entire time it's spent in the air would be the second time. Okay? But they're asking for 1152, so I'm going to make the assumption at this point that it's not the vertex, and I'll just tell you now it's not. So let's put into our own formula what we know. We're looking at 1152. This is our plane S. Our plane S is at 1152. At what height? 1152. So I'm going to put in my formula for S, 1152 equals negative 16t squared plus 288t. I'm dropping off the plus 0. Now in order to solve this as a quadratic, I need to factor it. It won't be so bad, trust me. We're going to fix those numbers. I don't like negative t squareds. Because the t squared is negative, I'm going to move everything over to the left side and set the right side equal to 0. So if I add a 16t squared, I get a 16t squared. If I subtract a 288t, I get a negative 288t. I'm not moving the 1152, so it stays positive. 1152 equals 0. All I did was take these, move them over to the left, which switched signs, and I wrote it in descending order. That would be a real ugly thing to factor. If I had to factor that, I'd use the quadratic formula. But 9 times out of 10 on these problems, everything's going to be divisible by a magic number of 16, which in this case it is. If it's not, then use the quadratic formula. Question? You just stretching. Okay. So I am going to attempt to on my calculator check. Are all of these divisible by 16? Yes, indeed they are. So I'm going to divide everything by 16 because I want my numbers so much smaller if I can get them there. And so I end up with t squared minus, I'll do the math for you, 18t plus 72 equals 0. So now that should be a fairly simple factoring where we just throw it into parentheses. The t squared becomes t and t. But now we have to find 1 times 72 is 72. We have to find the factors of 72 that add to give me 18. I'm going to help you along with that. That will be 6 and 12. 6 times 12 is 72, and don't they add to give you 18? For these to add to give me negative 18, what do the signs here have to be? Both negative, which makes sense because when we do t minus 6 equals 0 and t minus 12 equals 0, what is the value for t? So 6 and 12 seconds. So it's asking, when will the projectile be 1152 feet? Well, on the way up, this would be right here, 6 seconds. And on the way down, this would be your 12 seconds. So therefore, I ran out of room. So therefore, the projectile will be 1,152 feet at 6 and 12 seconds. So there is the sentence solution. Now we have one more part to this question and we're done. And this part doesn't require any work. It requires observation. Anytime you do a word problem, you should be drawing that picture because the picture is worth 1,000 words. And the second part comes into play with the picture. So, part B. Part B is asking, when will the projectile be at least 1,152 feet? It's a different question than the first question. The difference is the words at least. Think of taking 1152 and putting it either at the floor or the ceiling. If you put it at the floor, that means that you can get numbers greater than it. If you put it at the ceiling, it means it's a less than. You can get numbers less than that. So if I said you're going to get at least $1,152 for your allowance, wouldn't you love that? Does that mean you're going to get more than 1152 or less than 1152? More, right? You could get the very minimum you could get is 1152. So this is my minimum line right here. That means I'm going to go greater than. So I can go greater than or equal to 1152. That's what that's telling me. So what part of this graph is greater than 1152? Is it the outsides or the inside? It's this inside from here to here. So that's an interval, right, from 6 to 12 seconds. So therefore, and since I don't have a whole lot of room and we're running out of time, therefore it would be between and including 6 and 12 seconds. And you could write that in interval notation if you wanted to. It'd be brackets around the 6 and the 12 seconds. If they said, when will the projectile be less than 1152 feet, then you would have to say from 0 to 6 seconds and, or from 12 to, and you'd have to find what the other second was at a height of 0. So you'd have to actually do more work on that one. All right, so tomorrow